Good morning. Today we learn class 12th physics. Lesson first. Electric charges and field. Our topic is electric dipole. When we learn electric dipole, there are so many questions arrive in our mind. What is electric dipole? How it works? What is the direction of the electric dipole? Electric field due to dipole. So we should try to find out the answers of these questions. So we start. Electric dipole. Di means two. Poles mean two different type of pole, whether they are positive or negative, but their charges are different. Two charges are kept at certain distance or certain fixed distance is known as electric dipole. These charges are equal and opposite. For example, it is a positive charge. Suppose it is a negative charge. The center point or the starting point is O. Here the distance should be L. Here again the distance should be L. So distance between these two became 2L. Two equal and opposite charges placed at fixed or certain distance. That distance should be 2L, 2A, 2S is known as electric dipole. In dipole, electric field direction is from negative to positive, like this, from negative to positive. Electric dipole moment. First of all, electric dipole moment is denoted by P vector. Okay, it is for measuring the strength of the electric field. It is a vector quantity. The separation between two charges or two opposite charges and the direction is along the axis from negative to positive is dipole moment. Suppose is it negative charge and here it is positive charge Q. The distance between these two charges are 2L. So the direction of the dipole moment is like this. So here P vector. The dipole moment of an electric dipole is a vector whose magnitude is either charge times the separation between two opposite charges, these two charges, or the separation. The direction is along the axis, like this or like this, okay, when this is negative or this is positive. Dipole moment equals to either charge. So here dipole moment is P vector equals to either charge Q. A vector drawn from negative to positive charge, the vector drawn like this, the or distance between these two charges, 2L. Or if you wanted to find out the magnitude, so mod of P equals to Q 2L. From here you can say that dipole moment is a vector quantity, direction is along the axis. Okay, so P equals to Q into 2L or 2QL. The SI unit or the unit used for dipole moment is Coulomb meter. So is Coulomb meter, or in bracket Coulomb meter. Examples of dipole: initial, H2O, HCl, C2, H5, OH, CS3COH, etc. There are so many examples. For initial, Na is positive charge and Cl is negative charge. So dipole moment like this, the electric field. If another questions arrive in our mind, can dipole make electric field? Yes, dipole can make electric field. Okay. Another example of dipole, polar molecules. Polar molecules are those molecules which will show already the behavior of electric dipole like H2O. Polar molecules are those or these molecules which will show already the behavior of electric dipole. For example, H2 non-polar molecules. Whether non-polar polar molecules show the property of electric dipole or not. Non-polar molecules like CO2 carbon dioxide. C is positive charge and O has negative charges. When we see these molecules they will show properties of non polar molecules, but when we put it into electric field, it will or they will show the property or properties of dipole or dipole moment or like dipole molecules. Those type of particles particles. Those type of particles are known as known as non-polar molecules. Known as, for example, CO2, carbon dioxide, CH4, so on. In this video, we completely learn electric dipole. If you like this video, like it, share it, and subscribe it. Thank you.